All right, Algebra 1A students, welcome to part 1 of lesson 5.1. We're starting chapter 5 in this video, and we're starting with talking about slope and rate of change. Okay, the essential understanding here in this section is that we can use ratios to show a relationship between changing quantities like vertical and horizontal change. Okay, the change in the vertical versus the change in the horizontal when we're looking at a graph of a line, okay, graph of a straight line. So rate of change shows us the relationship between two changing quantities. And it's always a rate, which means it's a fraction. Okay, it's always a fraction. When one quantity depends on the other, the rate of change is given by the change in the dependent variable over the change in the independent variable. Okay, dependent variable in general is going to be our y values. Independent is going to be our x. So it's y over x, change in the y variable over the change in the x variable. Okay, y over x. Part of your homework is going to be to look at a table of values and decide what is the rate of change. Okay. Here's a problem that shows us the distance a marching band is marching over a certain number of minutes. Okay, so we have this relationship between the distance they're marching and the minutes that they've been marching. Okay, what they want to know is the rate of change in distance with respect to time constant? Meaning, is it a constant rate of change regardless of which minutes we choose? Okay, so the rate of change, remember, is the change in the dependent variable, which is distance. That's my y variable, over the change in my independent variable, which is my time, my x. Okay, change in distance over change in time. So the way that we usually do this, the way we find the change, is to actually subtract. Okay, we subtract two of these points. So maybe I'll take this point here and this point here. I'll subtract the two y values, and I get 260. That's the change in my distance. 520 minus 260 is 260. Dividing by the change in my time, I'll subtract 2 minus 1, which is 1. My rate of change is 260 over 1. Not something that I can reduce. Okay, 260 over 1. I could do the same thing if I did 780 minus 520. That's also 260. 3 minus 2 is also 1. 260 over 1. And then here, the last one, 1040 minus 780 is 260. We could use a calculator maybe for that one, or write it out on paper. And then 4 minus 3 is 1 again. Now the thing that I want to show you is that it doesn't actually matter which points I use, which 2 points I use. I can even take this third point, that middle one right there, with 3 minutes, and use this point 1 minute up top. Okay, and subtract there, and subtract here. Okay, so then what's 780 minus 260? Well, that's 520, if I subtract those, over, that's the change in my distance, remember, change in distance, change in my y variable, my dependent variable, over the change in my time, which is 3 minus 1, that's 2. But 520 over 2 can be reduced. What is it reduced down to? 260 over 1. So is the rate of change with respect to time constant, meaning doesn't change? The answer is yes. It does not change. What does the rate of change represent? Well, the rate of change represents the distance the band marches in every 1 minute. Right? The distance the band marches every 1 minute is what the rate of change means in this case. Okay? So that's what rate of change is. We find it a lot of times in real-world context from a table of values by subtracting the y values, subtracting the x values, and making a fraction out of them. Change in y on top over change in x. Okay? The other thing that this is called is it's also called slope. Okay? So when we graph a linear equation, the rate of change is called the slope of a line. Okay? When we graph a line like this, when we graph a straight line like this one is, The rate of change in this situation, the change in the y over the change in the x, is called the slope. Okay? Slope is the vertical change of your graph, meaning the change in the y direction, over the horizontal change, the change in the x direction. Okay? An easy way to remember this is that we say slope is easy and fun. Slope is easy and fun. Just remember rise over run. Okay? Rise means rising up, right? How high up did we start going? Rise up. How far up did we go? And then it's running over to the right, usually, almost always to the right. Almost always to the right. Okay. Rise over run. How far up did we go on the line? Over as a fraction. How far did we go to the right? How far over did we go? Okay. Now we could also have negative slopes, which would just mean down, up or down, right? Rise up or down, either one. Rise up or down. But when we find that fraction, that's called the slope fraction for our line. Okay. So I want to show you a couple of examples here where we're finding the slope of these lines. Okay, we're finding the slope of these lines. Here's a line that they've graphed right here. We can see a couple of points that it goes through because they show us right here and right here. Okay. To go from this point to that point, by the way, we always want to start on the left side. Okay, always start on the left side. Always start on the left. Always start on the left side. If we start on the left side, to go from this point up to this point is going to take me going up 2 squares and going over 3 squares. Okay? Rising up 2 squares and going over 3 squares. So the slope, remember, is equal to the rise over the run as a fraction. The rise in this case is 2. The run in this case is 3, because I had to go over 3 to go up 2, to go from this point to this point. Okay? Similar idea in part B, except now, again, we're going to start on the left side. So to go from this point to this point, to go from this green point to this green point, I have to go down, actually. My line is going down. Down 4 and to the right 5. Okay, the key with going down 4 is that my rise is now a negative number. The rise is now a negative number. When I go down, the rise is negative. Okay, the run is still positive. That's still 5 going that way. Okay, so my slope here is down 4 over 5. Negative 4 over 5 to the right. Okay, down 4 over 5. I've got a couple here for you to try. I want you to use these points here and here for that line, and then here and here for that line, and decide how much are you rising, how much are you running. Make me a slope fraction for each of these graphs. Okay, pause the video, take a look at that for just a moment, then come on back and I'll show you what we should have. Okay, the one on the left here, in part A, I'm going up 2 and running over 2, 4, 5. Up 2 over 5. The slope is 2 over 5 as a fraction. On the other one, I'm going down 2, going over 2, 4, 6. Down 2 over 6. Now, I would not want this to be our final answer, however. In our homework or on quizzes, we need to reduce our fractions. Dividing top and bottom by 2, we end up at negative 1 over 3. Okay. So there's your slopes. 2 over 5, negative 1 over 3. If you have questions about finding slope from a graph, finding rate of change from a table of values, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.